Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today is day 21 of the 28 Days to Phi journey, and we relax. Finally, right? So, personally, this day comes in a much needed time in this journey. I feel pretty exhausted from 3 straight weeks of uploading videos and connecting all of these middle school concepts as well as elementary to college concepts to one single special ratio, the golden ratio, phi, 1.618 as the numeric approximation, square root of 5 plus 1 all divided by 2 as the irrational approximation, and it is this beautiful ratio of our Milky Way galaxy as the Egyptians used it in building the pyramids, as we see on pine cones and shells. So today is a day where we relax. We let all of the understandings we've come to gather so far in this journey, and we are going to let them sink in. We're going to let them find their permanent places in our minds, in our mind map. So to relax today, to help our brains along that journey, what I'm going to do is create a drawing, a sketch of the mind map, reflecting on the last 3 weeks, untangling everything, helping my brain untangle it, taking anything that's still in this orb of short-term memory and help my brain link it in different places so that it stays long-term memory. If you like to doodle, if you like to draw, see, technology, still learning all the time. If you like to doodle and draw, I would hope that you grab a pen and a pencil and blank white page or blue page or graph paper page and do it with me. If not, you can just enjoy the show and see how I map all of these thoughts in my mind. So without further ado, let's get started. So in the beginning of our journey, we looked at the golden ratio as a golden rectangle, and we drew it, and we drew it a lot. So it really is off of the basis of this idea of a square. So you see here's a square, and the spiral of the golden ratio spirals through the square components of that golden rectangle. And then what you see is a reoccurring shape in nature. We see this spiral in my pine cone. We see the spiral in shells. We see the spiral in the galaxy. And one of our students is actually exploring the galaxy. And I think that it's really cool that the arms of the Milky Way galaxy actually represent the golden ratio. So the Milky Way is formed using arms that are spinning, and not all galaxies are these spirals, but our Milky Way galaxy is a spiral, and I think that's pretty amazing. So I'm going to use this spiral to help me make my mind map. Okay, so here we learned about ratios. We learned that the long side of a segment compared to the short side of a segment must be equal to the entire length compared to the longer length. Okay, so just like the value pi, a lot of students think of it as 3.14. Well, it's not really just 3.14. It's a really important ratio relating the circumference to the diameter. In this case as well, yes, we look at the golden ratio as 1.618 as a quick way for us to get an idea of what the value of that ratio is. So this is an approximate value of this way more important concept, comparing long to short, whole to long, okay? Because all ratios can either be part to part or part to whole. Okay? And when we built the Pyramid of Giza, we saw another really, really fascinating characteristic of phi, seeing that the hypotenuse of a right triangle that is a cross-section of the pyramid perpendicular to the base, intersecting the edge of the base of the pyramid at its midpoint, is this beautiful right triangle that relates phi to the square root of phi and 1. And that's not something we can say about its good old friend pi. Pi doesn't have this really cool characteristic where a right triangle formed with the square root of phi and 1 forms a hypotenuse of phi. So that's really, really fascinating, and it might have more connections that we've yet to uncover. So the fact that we know that this relationship is true, the square root of phi squared plus 1 squared equals phi squared. And if we simplify the Pythagorean theorem, Pythagoras, yes, we talked about Pythagoras. And Pythagoras is a really cool mathematician who created a school, and he got credit for this idea even though he was not the first to discover it. He just got the name. Very similar to the Fibonacci series. 1, 1, 2, you add the previous 2, you get 3, 5, 8, 13. While this is called the Fibonacci sequence of numbers, Fibonacci was only given the name to that sequence in 1877. But it was really discovered in the 13th century. In 1170 was when Fibonacci was born. So in the 13th century, he discovered it. But later on, people looked back into history and said, you know what, Mr. Fibonacci, he deserves the name of this sequence, so we're going to give it to him. And that idea kind of goes with Pythagoras as well. So this is looking back into the history of math, which is, if you're a historian, if you love history, I encourage you to navigate through mathematics with a historical lens and still connect with math. But Pythagoras was given the name of the Pythagorean theorem, even though he was not the first, nor the last, nor the only to discover that the square of one side of a right triangle, one leg, plus the square of the other leg equals the square of the hypotenuse. Okay? So, more so, we found another really cool situation in that the inverse of phi equals phi minus 1. Well, that's really interesting. The inverse of phi equals phi minus 1. We can't say that for pi. Pi doesn't have that really cool characteristic that the inverse, the multiplicative inverse, that's that flip. When you're learning about dividing fractions, like 1/2 divided by 1/3, that's the same as 1/2 times 3 over 1. That's the flip. This is the multiplicative inverse of phi. So if I were to multiply phi by this, I would get 1, the multiplicative identity. But that's the same value as 1 less than phi. That's pretty interesting. So the inverse of phi, if we look at the numeric approximation of that, the value, that's going to be about 0.618. And 1 less than phi is about 0.618. Fascinating. These numbers are just approximations for these really cool relationships in math. Okay, so let's keep going. We looked at dimensions. We graphed data. We did dot plots on different values we found in our nature object and try to find the center and the spread of our data. We also one-dimensionally looked at line segments, and we used line segments to look at the cross sections of a pyramid. So the edges of a pyramid have, if we were to slice them with that, what do we call it, the drywall putty knife, if we were to slice it right on this edge, we would get a line segment, and then we sliced this 3D solid. If we sliced it right on the edge of the face, we would get a triangle, and if we sliced it through the pyramid, we can get a variety of two-dimensional objects, okay? And they might look like a trapezoid. So the point of today is to let all these nutrients sink in. So I really encourage you today to relax and grab a blank surface, whether it's just you talk to texting into your phone, or if it's a whiteboard or a piece of paper. I want you to take a moment to dump everything out of your mind that you have already learned about in this process. There is so much goodness here, okay? We didn't even get to all the things that spiked my interest in this series, but it really is important for you to recognize that learning doesn't have to be linear. It doesn't have to be done in one phase of the sun, from sunrise to sunset. It does not. We did this journey in the phases of the moon, and this is the last phase of the moon. It's the full moon week. It's our week to relax, to let all the nutrients of our practice sink in. Okay, I had intentionally thought we would do an activator today with a piece of pizza. So let us close today with this pizza picture, really recognizing that math is everywhere, and I really encourage you to revisit any of the first 20 days of this journey to refresh your mind or practice something new. This whole week is designed for us to relax, reflect, take note of what works, take note of what we need, take note of our attention voids, where we lack attention and where we need to put attention, take note of our instincts, and shift gears so that we can serve ourselves and then our families and then our communities and then this whole great, wonderful world. So let's end today. I'm going to keep these videos short this week. It's all about you this week. What do you need? What serves you? What makes you a learner so that you can serve yourself and then serve others? So let's take a look at this pizza. What do you think? I see this pizza. I count 7 slices. What I think right off the bat is someone stole a slice, because who slices pizza in an odd number, let alone a prime number, 7? Okay. I also see that they're not quite equal parts, that if I were to dive in first, I might grab the bigger ones. They're a little bit more than a 7th. I also see that it's circular on a circular plate, and that relates to phi, because phi and pi are friends since they're both relating measurements. The circle of the plate has a diameter and a circumference, and that the pizza must have been much smaller because these pieces are spread out. If I only had something to scale this, like if I had a pencil or something like a quarter, I could scale it and say, how big is this pizza? I mean, is this pizza really the size of a saucer, or is it a typical pizza, or is it a small pizza? What do you think? Pepperonis are all different sizes. We can't use them as a scale. Scale models, scale drawings, that's something we've talked about this week already. It's really, really beautiful what math can do, how the perspective of mathematics can really liberate us from aggression. We don't need to get upset about math. So let's all have conversations about math, practice looking at things with other people's perspectives, not getting upset when they don't agree, and being a skeptic to challenge others' ideas. Sam here with Money Math. I'm going to go ahead and sign off. If you've been carving out from 9:30 to 10 for your 28 days to phi, I really encourage you to take the next 10 minutes to put all of your ideas from this journey onto a single place, okay? It doesn't have to be a piece of paper. It doesn't have to be a whiteboard. But I'm going to spend the next 10 minutes of my day really kind of organizing this and making it nice, and I'll upload it later. Stay tuned for my blog posts, more on the beauty of you showing up for yourself and the importance of this week. Don't skip this week. This week is what we worked for. We worked really hard for the first 20 days, and these last few days are really important to let the nutrients of our math practice sink in and help us to create a pattern in our lives where we can revisit these 28 days of learning, whether it's math, history, science, English, foreign language, taking care of dogs, taking care of the garden, cooking, baking, cleaning, what have you, whatever it is, this 28-day path to learning, I think, is a great format for you. Work really hard, your struggles are important, and then relax, reflect, take note. You got this. I'm so proud of you. See you tomorrow.